All right, so let's talk about mating in Fusion 360. Or my bad, I actually misspoke. It's called joints in Fusion 360. In other softwares like SolidWorks, it is called mating because you're putting two parts together. But there are two words that describe the same idea. The idea of creating virtual constraints to either lock components together completely or lock them together slightly and allow some degrees of movement. And we're going to be demonstrating this with an example here of some metal pieces that make up the chassis called AM14U4. That's, I think, relatively well known in the first robotics competition world. Though if you're not in that world and you're watching this tutorial for Fusion 360, that's the context. And essentially what we want to do is we have this end plate here, and we want to attach this like side outside plate. So if you imagine the front and back of a rectangular robot, this piece here is the piece that goes on the back and front, and below, this is the piece that goes on the side. So the first thing that we can do here is we can lock this piece down. If we only want one of them to move, and say we want to use one of them as a reference point, I don't think you have to do this per se, but it can be useful. So you can just right click it in here and hit ground, and it will lock it in place. So yeah, so just continue. And you can see when I try to hover over this, it can't move, but I still can move this one, right? And you can see that the plane there sort of moves in response to it. So say we want to connect these. This is actually around the wrong way. Say we want to connect these two holes to these two holes over here, right? Because say that's where a nut and bolt goes through. So we hit the joint tool by either clicking up here under the solid tab or pressing J or pressing S and typing joint and selecting the correct option. Just a joint, not an as-built joint, because I want to demonstrate a few things with this. And we select, say, this circle here, and then we select this circle here. And you can see it displays an animation of it swiveling around. Normally, it will just be a rigid joint. This is the joint that it is by default, but you can change it to revolute or you can change it to cylindrical, which allows it to go up and down in addition to spinning. So if we hit OK on this, you can see that it'll lag for a second because I'm using a hard drive and not an SSD. It will go up and down and it will swivel around. The way you control the movement can be kind of weird because you're looking at it from a camera that's sort of looking at a plane while it actually exists in a 3D space. So if you go below, for instance, let's click bottom and align ourselves. Maybe we can rotate it around a little bit better, but the amount it will raise it by can be a little bit random seeming. So let's lower this back down to make this a little bit more sane. And let's do the next step of this. So obviously, if we want it to look something like this, right? Say, let's just try and align this in the correct position. We probably don't want it to be able to rotate around freely, like if this is a part of the foundation of our robot chassis. So here's how we can fix that, right? Let's just move this out of the way a little bit. Doesn't really matter how much we rotate it. And we go back in, I'm having to scroll a lot, and we select, and this is important, selecting not the inner cylinder, but the top outside circle. And then we go under here and we select the bottom outside circle. Yes, continue. And then don't select cylindrical, but select circular. Or sorry, it's actually called revolute. The important thing about this is that it will essentially match the circles together, as opposed to allowing them to float freely. Because as far as I can find, there's not really a good way of saying align this top plane here to this underside plane here, and having the circles on the bottom part of this end plate and the top part of this outside side plate is one way, likely of many ways, to get it to work. And now say if you wanted to add nuts or bolts into this, you could stick a bolt through here and attach a nut underneath, right? Using this feature. So now let's hit OK, and now we'll see. And if we think about it geometrically, if we try and move this, it won't move because we've defined two circular joints, defined two things on a circle. They can't really move if they're attached to 2 points. And we've also locked its ability to move up and down. So you can see here that we've created a pretty solid joint. Now, for the sake of the demonstration, let's just do it one more time. And here, let's just do an inside rail, because this is an interesting and different looking piece, right? So let's move this over here. We'll rotate it so it's the correct direction. Technically, we don't need to do this. And we hit OK. There's actually some number of holes inside that it's supposed to be. I think it's 8. It's possible this is wrong, but not really relevant for the sake of this example. And we'll actually do this top of the circle this time, right? And we'll count inwards 1, 2, 3, 4, 5, 6, 7, 8. Click on this, and you can see it sort of aligns, and the planes are also aligned, right? So now if we hit OK, perfect, we can see it revolutes. But we don't want it to do that, right? We want it to be sort of perpendicular. So if we move this, actually it's probably better if we move it out here, and we click the joint button again. We click this circle, we go underneath. Oh God, we go underneath, and we click this circle, yes. We hit OK. You can see that it's in the correct place because the geometry of the joints compelled it to be in the right way, right? And this is the side that's supposed to face out. This other side is the side that's supposed to face... Sorry, it's the other way around. This is the side that's supposed to face out. This is the side that's supposed to face in. For the sake of this example, though, that's technically not relevant either. To demonstrate that you can link things together via the places where you would put bolts through. And then let's just for fun add one more on. Let's get an end plate here. Let's move it around. We can rotate it a little bit. Actually, yeah, so let's rotate it to a weird angle that maybe you wouldn't normally do. And I'll show you that it works at whatever angle, right? So let's do joint again. And let's do one here, one circle on top, and then the circle underneath here that we joint together. And you can see that even though this thing sort of moves away from its diagram, when we hit OK, this is the one that's being moved because we locked this one down earlier, right? You can see here, there's a little pin icon if your resolution is high enough. And if we right click it, it'll say unground, as opposed to if we right click the others, it'll say grounded, implying that this component over here is grounded, which is what we want and is why this piece here did not move over to this one when we jointed them together. Now, what you see what happens is it'll rotate around. If we click on it and hold, we can spin it pretty quickly. But we don't want it to be like that, right? We want to sort of lock these together. So we can do another joint, and we can click this. We can go underneath here, and let's count carefully. 1, 2, 3, 4, 5, 6, 7, 8. And hit OK. And when it stops lagging, we can zoom out, and we can see that these are jointed correctly, and this does not move. Because 2 points, these things are locked down because this is locked down, and these are locked down onto it because of their joints, and this is locked down because it has 2 joints onto it that are preventing it from rotating. And let's just real quick attach the other ones onto here so you can sort of see what it looks like. So we'll do this, and we'll rotate it a weird amount, and then we'll go and hit joint, and then we'll do this, and then we'll go 8 in on this side. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And it doesn't matter that it looks like this, that it is actually merged in kind of humorously. If we do this, probably we don't want to do that because we want it to be visible, right? Joint, click the circle. And then we can also go over here, count 8 in again, 4, 5, 6, 7, 8. And it will lock into place, right? And then let's just do the last one, outside plate. Just drag this into the middle, rotate it around a little bit, hit OK. And let's do the last one. Joint, circle. Well, we'll actually do it in an alternate way. For the sake of demonstration, we'll do it with the cylindrical one. And then we will attach it to this. And you can see it can go up and down in addition to rotating. It's locked like that. Let's just move it out a little bit to make it more visible. So we can click the hole. We'll go to joint, change it to revolution motion. Click this circle on the top. Go over here. Click this circle here. And it will attach itself correctly. And now, none of these components will move because they're all locked into place and they correctly make up the chassis. And if you go over here, you can click, I think it's V to hide? Yeah, it's V to hide. So if you click on something and tap V on your keyboard, it will hide it. You can go back into the side here and find it if you want to unhide it. But personally, I don't like these things to be visible because I think they're a little bit ugly. But so nevertheless, this is our chassis. And I think this looks pretty good. All the joints work correctly. Nothing moves. And that's basic jointing, using the joint tool, pressing J, attaching things together.